Hello everybody, and welcome to this video where I'll give you a more thorough introduction to regression analysis and part 3 of the work requirement. As I understood, some of you thought that my video on the third part was a bit brief, and some of you want more explanation as how you interpret the regression analysis. This video will give you a thorough introduction to or explanation as to how you can interpret regression analysis. And I'll use the example that I've used through the whole work requirement. So yeah, let me just show you. I made several documents. I made this, which I've called Overview of Regression Model and Results. This is my example. And as I've really emphasized a lot, you have to know the values on your the different variables. So on my in my first model in my bivariate regression analysis, I have done a regression analysis on status cannabis, where I've turned or flipped the scale. So now in the initial variable 5, the value 5 was that it reduced your social status a lot, and 1 was that it increased your social status a lot. But the interpretation is kind of hard to get then, so I turned it or flipped it, and so now those who have a high value on my first dependent variable, they say that it increases your social status a lot to smoke cannabis. And in my stepwise regression analysis, I've made an index called status intoxication, which is a sum of status cannabis flipped and status drunk flipped. Let me just emphasize, you don't need to make a sum variable or index variable. It's just for those of you who want to do it. I show you how to do it. So it's not necessary. You can just use one question. But if you want to make index, I'll show you how to do it. And then I also included overview of my independent variables with the values, the lowest value and the highest value. So I can use this for my interpretation. It makes my interpretation so much easier to have to know this. Okay. I also actually in the regression table I've put in the highest and which are the highest values for the dummy. I put in the reference category, which is boy, and that's the low value on that one though. But yeah, that's what I do. And I also made this input, interpretation, regression, and results. You can put in your name there. So if you provide me with this information, your information about your dependent variable, if you just have one question, just put in one question, not the second. Or if you have made an index of 3, for example, please put that in. And your independent variables, adjust the table according to the number of variables you have, but you have to have at least 5 independent variables though. And then put in the results. And you can send it to me by email Wednesday afternoon by the latest. And I'll include this in my lecture on Thursday, interpreting your regression model. And I'll make a video of it as well. So I'll interpret your regression model. And some of you also thought that this table was a bit tricky to understand. I also put it into here. It was a bit, because you said, okay, there's like XX after the independent variable dummy. Well, this is just an example. So you have to really fit the table so it corresponds with your model. So everything is an example. You just have to fit it so it really fits with your model. And this is me. I have fitted this table so it corresponds with the model I've used. So you see it's somewhat smaller. Yeah. So now I'm just going to show you how I done these the recodings and run the analysis. And I also have to say I have made a syntax, which I've called syntax part 3 work requirement, where I really show you how I do the analysis I've done. And for those who so you can really just take, if you use youth data, you can take the data set and you can rerun this. You can just run this syntax and you will get exactly the same results. But I put all of this on Canvas. But as I said to you, if you want me to interpret your results, and then I'll make a video of it, of course, so everyone can see it. I'll not tell your name or anything, but I'll make a video of the results so you can really interpret the results. But Wednesday afternoon at 3 is the deadline for sending me these results if I'm going to use it in the lecture. And if many of you send me the results, I'll pick the first ones, but I'll put everyone into a video at least. Okay, so how did I get to these results? Well, if you look at my syntax, the first thing I do, I say I'm going to run a bivariate regression analysis. But first I flip the scale on status cannabis, which is the depend variable in the bivariate regression analysis. So I do a recode. If you want to do a recode, as I showed you in the previous video, you don't go for compute, sorry. You go for transform, recode into different variable, and you get the whole recode command here. I showed you that in the previous video, so I'm not going to show it here, but you can also just copy paste this recode command where I say status 4, put 1 to 5, 2 to 4, 3 to 3, 4 to 2, and 5 to 1. So I flip the scale and I call it status cannabis flipped. I change the names and the labels, so you have to do that. And I then run it, and in my output, where's my output? Come on. There's my output, yeah. Then it says I've recoded status 4 like this, and everything is okay. As you see, SPSS gives you all these kind of warnings, but don't. If everything works fine, it works fine. And then I check whether the recoding was correct. So I used the initial variable and my flipped variable. And now I know that. Because some of you would say, oh, why do you know that increase your social status a lot is 1 on the previous variable? Well, I know because I went into the data set and I looked at status 4 and I say, okay, 1 is it increases your social status a lot. I can pull this up. And 5 is it reduces your status a lot. So I know from before. So if you don't know the values on the variable, you have to go into SPSS and look at it. But now I know that increase your social status a lot is 1 on the initial variable, but on my recoded one it's 5, and increase your social status is 2 on the initial variable, but it's 4 on my flipped or recoded variable. So now the scale goes the other way, it's flipped. Okay, so now I look at the high value is those who say, well, it increases your social status to smoke cannabis, and that makes it so much easier to interpret the results. When I'm now performing bivariate regression analysis with status cannabis flipped as dependent variable and age or class as independent variable. And as I told you previously, in Norway, people don't flunk classes, so they don't drop. You don't drop down or you don't stay in the same class. You proceed according to your age. So class and age is perfectly correlated in Norway. And I then run my regression analysis, and what do I find? Well, I find that class or age explains 4.4. This is a proportion, so it's 4. I multiply it by 100. It explains 4.4% of the variation in in smoking cannabis, or status you get from smoking cannabis. And what have I done? Well, if you look at the overview regression model and results, I'll put this into Canvas so you get it. But then I'll put it there. Okay, so R square is 0.44, which means we explain 4.4% of the variation in status cannabis, which is the dependent variable. And then I don't look at the ANOVA table, but I look at the I can just, you know what? I can make this. I can zoom in, so I can take this to 150, so it's easier to see. I can take then I go to the coefficients, which is this is the regression results, and I take the constant and 1.345, and I put in here. Oh no, sorry, there. 1.345, and I put in the standard error, the SE. I put it there. Okay, and the interpretation of the constant is that this 0 has to be a substantial value on the independent variable for me to interpret the constant in a substantial way. However, class or age goes from 1, I can see it here, it goes from 1, year 8 in secondary school, to 6, year 3 in high school. So it doesn't have 0 as a substantial value, so I cannot interpret the constant. That will be the answer to the questions, or to the interpretation of the constant. If, though, I had recoded age or class, so 0 would be year 8, 1 would be year 9, and so on and so on, I could interpret the constant substantially, and that it would then be the mean value on status cannabis for people in the 8th year of secondary school, or 8th graders. So then it would be that would be the mean value on status cannabis for people in the 8th grade. But given the fact that I have not recoded it from going from 0 and onwards, I cannot interpret the constant substantially. But this coefficient, which is this one, and its standard error coming from putting it in there, and this one I can interpret substantially, because and the constant and the coefficient is 0.144 or 0.144. It's less than 1. It's 0.144, though I don't, you have a point in front of 1, but I don't put in the 0, so you don't usually do that for regression coefficients. You just put in 0.114, for example. This means, given that the status cannabis goes from reduces your social status a lot to increase your social status a lot, well, it's a positive coefficient, so as I go 1 scale unit up on class or age, going from the 8th grade to the 9th grade, the status cannabis increases with 0.144 scale units. And if I go from the 9th to the 10th grade, it also increases with 1.44 scale units. What does this mean? Well, it means that the older kids think it increases your status more to smoke cannabis than the younger kids. Well, there's age difference. Many of you want to interpret this as you grow older, but this is a cross-sectional data set, so it's different. The difference between different age groups, and the younger thinks it's less cool to smoke cannabis, the older thinks it's more cool, or it increases your social status more to smoke cannabis. Can I generalize these results to the population? Yes, I can, because it's significant. And it's significant. I can be 99.9999% sure. You find the level of significance here, and and it's highly significant. So I put in three stars. So okay, that was the interpretation of the first bivariate regression model, and as you can see, I have to know know the values on the different variables. Okay, so then I go back to my syntax and I do the recoding. I recode to dummy variables, flipping the scale and construction of index. That's what I'm doing. So first I'm going to recode gender to a dummy variable before the regression analysis. As with flipping the scale, you go to transform, you go to recode into different variables, and since I've showed you this in the previous video, I'm not going to show it again, but that's what you do. Or you can just if you want to recode a dummy variable, you can also just go into my syntax, which I'll put it on canvas, and copy paste it and then change the values. But I'm just going to recode this, and it says, well, it went okay. And if I wanted to check if the recoding went well, I can also run. I could also run a frequency between the original variable and my dummy gender, but I'm not going to do that. And then I also have to flip the scale on status drunk, because that's going into my sum variable or my index. So I do that, and that went okay. So I want, because I want getting drunk to be the high value. It increases your status slot to get drunk. And then I'm going to run the frequency between the initial variable and the status drunk flipped to see whether I was able to turn or flip the scale, and I am. So the 423 people who said it increases your status slot, they had 1 on the initial variable. And remember again, I know that they have 1. I've written it down, or this is actually the flip one. But I know, because I went into the syntax and I saw that, well, increases your social status a lot is 1, and reduces your social status a lot is 5. But when you work a lot with data, you know this, you know it. So then I know that this is 1 on the initial variable, and it's 5 on my flipped one. And it reduces your social status slot. It was 5 on the initial, it's 1 on my flipped, because I look at those who say it increases your social status to get drunk, and I want to merge that with cannabis, because I want to look at those who says it increases your social status to get intoxicated. Okay, so what do I do? Well, I've done that, and I checked that the recoding went well. So I just use the compute to make this status intox. Creates an index sum variable of status cannabis flipped and status drunk flipped. This will be the depend variable in the subsequent regression analysis. The new variable will be named status intox. And as I said, you don't have to do this, but I'm doing it for those who want to do it, to show you how to do it. And you can add more variables here if you want to have like 3 or 4 or 5, but then you have to change the number here according to the number of variables. You have to divide it by the number of variables. And for those who don't want to use my syntax or don't want to write this down, you can go to transform and then compute variable, and then use this command. So put in the name and then the expression here. But I also showed you this in the previous video, so I'm not going to show it here. And then you run it, and voila, it went well. This, you can run a frequency on this status intox, and you will see that it will still go from 1 to 5, but given that it's a mean, it's the mean on these 2 variables, it will be more fine scaled, because you will have also get the numbers, or you'll also get the numbers behind the comma. So you'll get the decimals really. I can actually show you if you want to. I can run a frequency. I'm not going to paste it, but I can show you. So you see here, some will have you got this 1.5, 2.5, 3.5, 4.5. So it still goes from 1 to 5, but it's more fine scaled because you get the decimals as well. And if it was 3, you would get even more decimals. So, okay, I've done that. And now I'm going to run the multiple regression analysis. And so status intoxication is my dependent variable. I use class or age as in the first model. In the second one, I use class and their relationship to their parents, whether they argue a lot with their parents or not. And this also goes into my third model, but also I have also whether they enjoy school, how they fit in among the other students, and my dummy for gender. And I run that. And I go to my model summary. I have the adjusted R squares here. And what do I do with them? Well, and again, I have to keep in mind how these different variables are measured. But anyway, I put the R square. Oh, sorry, I didn't change. Well, did I? Status intox. Yeah. Well, anyway, I got a bit different. What's the result? The result is a bit different. This is strange. Constant 3.6. 3.7 in the second model. Yeah, well anyway. I'm not really able to say why, but the R square went a bit up. So, well, anyway, I can show you. I put it in like this. No, sorry, I'm looking at the wrong. No, I'm looking at the right numbers. So the R adjusted R squared, 12.5. Maybe I forgot to change for. I run the same model on the Norwegian data set, but the both data sets are based on a 10% sample of the initial youth data sets, because the initial youth data set is so huge. So the results differ a bit between the Norwegian data set and the data set you use. So it might be that I actually forgot to change R squared, so because it's a bit different samples, but the results shouldn't be significantly different. Okay, anyway, I put in the R square here. So the first model explains 12.5% of the variation in status intoxication. The second one 15.6%, and the second last one 17.6%. Percentage of intoxication. And then I just don't look at the ANOVA table because that's not so important. It's not important at all because we are running a regression analysis. And let me just show you. I'm going to put this away. Where is it? There it is. So now I'm going to put in. Okay, so I put in 1.350 into the constant. I find that there, and I put in the coefficient for class or year 0.236. I put it in there, and I put in the standard error, which I find there, and the standard error, which I find there, into the model. Again, this constant would be, you could interpret this constant substantially if 0 was a valid value on the independent variable age class level. It's not, so I cannot interpret the constant as the mean value on index status intoxication for 8th graders, because the 8th grade isn't 0, it's 1. So I cannot interpret this constant in a meaningful way. So that would be the answer to that. But this I can interpret in a meaningful way. And it says that as you go one scale unit up on age or class level, you go from the 8th graders to the 9th graders, the index status intoxication increases by 0.236 scale units. And what does that mean? Well, the older kids compared to the younger thinks it increases your status more to get intoxicated. And the difference between the 8th grade and 9th grade is 0.236. The difference between the 9th grade and the 10th grade is 0.236, and so on and so on. So if you want to find the difference between the 8th grade and the and the 10th grade, you have to, that's 2 years, you have to multiply this by 2, for example. So then you find the mean difference on index status intoxication between different age groups. And in my second model, I've included argue with parents. And as you can see, I also put in not true at all is the highest value on the in this variable. I have it here as well, but for me to remember it is nice. So because this is negative, the coefficient is still not. I'm not able to. I found the constant, the coefficient for the constant. I found it there, and it's not. It's a 1.98. Okay. 1.98, and yeah, it's not. You cannot interpret this in a meaningful way because it's actually 0 is not a valid value on either of these two independent variables. So, and that would be the answer to the interpretation of the constant. Whereas this one is negative. So, if you go 1 scale unit up on argue with parents, the status, the dependent variable index status intoxication decreases by 0.204 scale units. And what does that mean? Well, it means that those who says it's less true that they argue a lot with their parents, well, they do not think don't think it increases your status, social status, to get intoxicated. So those who have and I will interpret that as something like those who have good relations with their parents. They don't argue with their parents that much. They think it gives you less social status or a lower social status to get intoxicated. Whereas those who argue a lot with their parents, they think it actually increases your social status to get intoxicated. Controlled for age or class, because when we include another independent variable in our model, we control for this variable. And so this is the effect of age controlled for whether you argue with their parents or not. So yeah, but let me explain the whole controlling thing by looking at the third model. And as you will see, 2.37, I found that one there, and the standard error I found there. And also when I want to see whether they're significant, actually there is one that is not significant here, because you can see that fitting in among the other students is above 5%. The p-value is above 5%, so it's not significant. However, yeah. So here you can see that there is still a difference according to age when I control for these other variables. But the argue with the parents goes down quite a lot, actually, when I include enjoy school, where totally disagree is the highest value. You can also see that here. And fit in among the other students is not significant, so it's not of importance. You still have to report the non-significant results because that's interesting. And the gender, there's a difference between boys and girls. But let's get to the fact that this goes down when I control for enjoy school, fit in with the students at my school, and gender. Well, why does the impact of argue with parents go down? Well, it's my interpretation of this, and this is kind of the, when I say look for interesting changes in the coefficients, well, it might be that those who argue with their parents, it's not the fact that they only argue with their parents, but they also doesn't enjoy school at all. So these kids that argue a lot with their parents, they also doesn't fit into school. They don't enjoy school that much. So it's not just that they argue with their parents, which explains their thoughts about the status they get from being intoxicated. It's also the fact that they don't fit into school that much. So some of the arguing with the parents go via or is eliminated by the fact that these kids are also known by the fact that they don't enjoy school. They don't feel like they don't like school, and maybe maybe they're also a bit this is higher among the boys. Boys argue more with their parents, so it's not just arguing with their parents, but it's being boy not fitting into school, for example, or enjoying school. So that's my interpretation of that. Some of the effect of arguing with parents is eliminated by the fact that, or is explained by the fact that these who argue a lot with their parents also don't enjoy school, and they are boys. That is the interpretation of why this goes down. But anyway, and to interpret the enjoy school, well, given the fact that totally disagree is the highest value, well, as you go one scale unit up on enjoy school, meaning you don't enjoy school that much, the mean or the value on the index status intoxication goes up by 0.185 scale units. And you can generalize it because it's significant. Meaning that those who don't enjoy school that much, because the highest value is that they totally disagree, they say that they say that it increases your social status to get intoxicated. So those who don't enjoy school says it increases your social status to get intoxicated. Control for age, argued parents, fit in with the students at my school, and gender. And fitting in with the other students is not significant. So there is no difference according to how the feeling of fitting in with the students at the school. But there is a gender difference, and it's significant. So you can generalize this to the population. And given that boys is the value 0, I have that here, but I also put in that it's the reference category here, and girl is 1. Going from one scale unit up on gender, going from 0 to 1, reduces the value on index status intoxication by 0.11 scale units, which is then the mean difference between boys and girls. So girls think it reduces your social status to get intoxicated, or said the other way around. Boys thinks it's more, it increases your social status to get intoxicated. So there's a clear gender difference, and it's boys who thinks it increases your social status more to get intoxicated. It's negative. Thus, the low value on gender, which is boys, go together with the high value on status intoxication. So if you have a negative coefficient, the low value on the independent variable goes together with the high value on the dependent variable. And furthermore, enjoy school, it's positive. So high value on enjoy school, totally disagree, goes together with, yes, it increases your social status a lot to get intoxicated. Okay, so that's the interpretation of, and I've interpreted the R square for you. So this is the interpretation of the different models in my example. If you want me to interpret your models and help you doing that and use it in the lecture for Thursday, you have to fill in this form, send it to me by email at 3 o'clock on Wednesday, the latest. If many of you send, I will take the first ones. First ones, but I'll make a video of everyone. So it's really, you have to, but then you have to fill in the information. Okay, I hope that provided you with some more info into the interpretation of regression models, but we're going to work with this on Thursday and also on the last lecture in March if you want me to do that, because yeah, that's up to you really. Okay, thank you so much.